Hello everyone, my name Sachin Rathod, working as assistant professor in Department of Mechanical Engineering from Walchand Institute of Technology, Solapur College. So today we are dealing with the unit, that is the design of the clutch, from the subject transmission system design. So the learning outcome of today's session is, at the end of this session the learner will be able to calculate the torque transmission capacity of single plate clutch. So introductions about the clutch. So the clutch is nothing but the device to transmit the rotary motions of one shaft to another, the axis of which a coincident is known as a introduction. The device used to transmit the rotary motions of one shaft to another and the axis of which a coincident is known as the clutch or a frictional clutch. So we will see in brief what is meant by that. So this is the driving shaft and the driven shaft. Okay, so just I will use the highlighter here. Okay, this is the driving shaft and this is a driven shaft. So if I want to change the gears, at that times the driving shaft should be disengaged from the driven shaft. So for that purpose we are introducing the clutch. So if I am going to check the construction of this clutch, so basically this is a kind of the single plate clutch. So just we will see the how the constructions of the single plate clutch is there. So the driving shaft is going to connect with the flywheel. This is a flywheel we can call. And if I am going to observe the driven shaft, on the driven shaft there is a pressure plate is there, and on the driven shaft the hub is there, which is going to slides over the spline shaft, and to the hub the clutch plate is going to attach. So this is the constructions of the single plate clutch. Now we will see how it is going to work. If I am going to press this paddle, so this is a paddle. If I am going to apply the force P, then the paddle will get placed. Because of the pressing actions, this pressure plate, the pressure plate will get separate out from the clutch plate, so that the driving shaft will get disengaged from the driven shaft. Then when we are relieving the clutch paddle, then again it is going to engage with each other, so that the motion from the driving shaft it is going to shift it to the driven shaft. So here if I am going to observe here, the clutch plate is there. This is a clutch plate. With the clutch plate it is having the frictional lining, because there should be the friction in between the pressure plate and in between the friction lining and the flywheel. So this is the basic construction and the working principle of the clutch plate. So now so there are total four. Generally we are using the four types of the clutch plate. So first one is a single plate clutch, second one is a multi plate clutch, third one is a cone clutch, and the last one is a centrifugal clutch. So from that the first one we will see, that is the single plate clutch. So whatever we had observed, this figure is for the single plate clutch. Okay, so this is it is also called as a disc clutch or the single plate clutch. So now we will see how to calculate the torque transmitting capacity of the single plate clutch, because ultimately we should know that how much torque should be transmitted by the clutch. So what is the capacity of that? So these are same diagrams here I have drawn. This is the driving shaft, this is the driven shaft. In between that the clutch plate is there, and this is connected to the flywheel, and this is connected to the driven shaft. Okay. So if I am going to press the paddles, it is the pressure plate will get relieved from the clutch plate, so that the disengagement is going to occur. So here the one side view is drawn here. So from the side views this is the OD. You can see that D, capital D is nothing but the OD, that is the outer diameters of the friction disc. Small d is nothing but the inner diameter of the friction disc. So if I am going to see, this is the this is the OD, and this is the ID. We can call this from these positions, it is ID. Okay. So it is indicating by the letter capital D and the small d. Next one, the small p is the intensity of the pressures at an radius r. So just for finding the torque, we have to consider the elements. So here we have to consider, just I will use the pen, sorry, excuse me for that. So this is a plate we had to consider. On that particular plate at the radius r, the intensity of the pressure is small p, and capital P is nothing but the total operating force in the newtons, and the MT is nothing but the amount of the torque transmitted by the clutch. So that things we need to find out. So the intensity of the pressure P at an radius r may be the constant or may be the variable. Just consider that we are having the new clutch. So there we are observing that the pressure is going to, the pressure will be gets uniformly throughout that the clutch plate, and that is in between your the friction lining and the clutch plate, also with the flywheel and the pressure plate. So there we are getting the uniformly pressure distributed, but as the it becomes the old, then the pressure is not going to distributed uniformly. There we are going to consider the uniform wear theory. So that things we are going to observe in the next. So consider the elemental rings at an radius r and the radial thickness dr as shown in the figure. So just now we have discussed about this figure. So in that just you consider the small ring. So this is the area, in which we are getting the friction. So just I will draw here also. We are getting the friction. So in that we have considered the smaller area, this. We have considered the one elemental ring to find out the total amount of the torque. So for that ring, the elemental area that we are knowing that the area of this ring is 2 pi r dr. Then we can calculate from the elemental area, the elemental axial force, that is the pressure intensity P into the area. We are getting the force, that is a 2 pi into P into R into dr. Then the elemental frictional force, that we have to consider the coefficient of friction mu into the force. So we are getting the mu into P into 2 pi r dr. Then the elemental frictional torque, that is for getting the torque, we are knowing that the frictional force into the radius r, we are getting the frictional torque. So just now we have discussed that there are the two theories are used to obtain the torque capacity of the clutch. They are called uniform pressure theory and the uniform wear theory. So in that first one we will see what is in by uniform pressure theory. So in case of the new clutch employing a number of the springs, the pressure remains constant over the entire surface area of the friction disc. With these assumptions, the P, that is the intensity of the pressures, is assumed to be the constant. So by that we are knowing the elemental axial force, that is a 2 pi into P into R dr. So already we have seen that equations. For the, we can call for the elemental ring, the axial force is this. Then for getting the total amount of the force capital P, we have to integrate from, just I will draw here the figure. So this is our the two rings are there. This is a center. In between that, this is a friction lining is there. So I have to consider this area for getting the total amount of the pressure. So this is the small, we can call this is a diameter, small d, and this is a capital D, right. So here we need to find out the amount of the total pressure. So we are getting that P is equal to 2 pi in, we have to integrate for, as we consider the smaller ring, that we are integrating from this surface to this surface. So integrating d by 2 to d by 2, that is nothing but the radius small r to the capital R. In brackets we are getting the same term, that is a P r dr. So as a P is a constant, we have to take it outside. So we are getting that 2 pi P in integration of the d by 2 to d by 2 r dr. Just integrate this, we are getting this equation, that is the final equation, that is the total amount of the pressure is going to exert over there, the total amount of the, we can call as axial force. Then the elemental frictional torques, already we are knowing these equations in the last PPT. Then as the elemental frictional torque is this, we have to integrate this from small d by 2 to capital D by 2, we are getting the total amount of the torque. So just after the integrating, we are getting the total amount of the torque is this, that is a pi into mu into p divided by 12 into d cube minus d cube. So this is the total amount of the torque. Just I am dividing this torque with the total amount of the force. Just excuse me for this, I will erase. If I am dividing this torque with the force, then I am getting the total amount of the torque that is acting over the clutch plate, that is mt is equal to mu into p is nothing but the total amount of the force in bracket d cube minus d cube divided by 3 in bracket d square minus d square, where the capital D and the small d are the inner and the outer diameter. P is nothing but the total amount of the force is going to act, and mu is nothing but the coefficient of frictions. So like this way we can calculate the torque transmitting capacity of the single plate clutch. Then the next one, that is a uniform wear theory. So for the uniform wear theory, that is a P into R is equal to constant, as the wear we are considered the uniform. Then the maximum intensity of the pressures, it is a d by 2 we are getting at that particular inside area, we are getting the maximum intensity. Okay. For this, I have taken a reference from the V.B. Bhandari book. Thank you.